Right. Hello, grade 12s out there. Hope I find you well. My name is Makore. Welcome to um, EduBlush Visual Academy. We are a group of professionals seeking to aid or to help grade 12s in their preparations. Okay, right. Today, I want us to go through functions and graphs, or you can say functions and their graphs. Okay, functions and their graphs. Functions and their graphs, it's not something that is starting now. It's something which was developed as early as grade 8. In grade 10 and 11, we also um, looked at some basics that were very, very important for you to comprehend and understand what you expected to resonate in your grade 12 class. Right. In grade 10, you looked at different types of functions: a linear function, a quadratic function, an exponential function, a, um, um, a hyperbolic function, and trigonometric functions. All those were functions that you guys acquired the previous grade. And up to this end, you guys are able to identify all these functions, both algebraically and graphically. When a linear line is drawn there, you should be able to pick that this is a linear line. When a quadratic graph is drawn there, you should be able to tell that this is quadratic, and algebraically, you can also say this is algebraically. This is algebraically representing a quadratic function. Okay, right. So today I want to introduce yet another function which is coming in grade 12. Very, very, very important. This function is called a logarithmic function. A logarithmic function. In short, they can just call it a log function. Or if you see presenters or teachers, they can actually just say log function. Just know that they are talking about the logarithmic function. Okay, right. Now, it is important for us to appreciate this function. And the biggest question is, why do you need to know this function? Where is this coming from? Why this function? Was it not enough that we got all the other functions that we had in the lower grades? What necessitated the development of this function? Okay, just to give us a brief, allow me to go to the board, then I'll start explaining and showing you what really necessitated this logarithmic function. Okay, right. Let's go to the board. Let's go to the board. Right. If you come now to your board, you realize that if you realize that there is a very, very strong relationship between an exponential function and a logarithmic function. Okay, right. There is a very, very strong bond between the two. Let me not unpack the lesson. Let me take you one step at a time. Okay, right. So I want us to look at what we call the log or logarithmic function. The logarithmic function. Sorry about my board there. Things are not coming out well. Let me try to write it again. Allow me to just delete that. Okay, right. I'm talking about a, oh, that's much better. Logarithmic function. A logarithmic function. Okay, let me underline that. Thank you. A logarithmic function. Okay. Now, using all the functions, using all the functions, we know so far, it remains impossible, and I'll underline the word impossible there, to make y subject of the formula to make y subject of the formula in the equation below. Right, I've got an equation x equal to a to the power of y. I'm sure you guys, you were exposed to making y subject given linear function, given different functions. Now someone says make y subject in such a case, it remains impossible. It's difficult at this end. Okay, right. This is what necessitated the logarithmic function. Look at this quick illustration. Let's look at this quick illustration. If you remember very well, I'll take you to your grade 10. Let me take you to your grade 10 class. I'm sure you passed your grade 10. Right, look at this. Let's just look at a quick illustration. I'll take you to an exponential equation. Something like this. 2 to the power of x is equal to 8. Then they say solve for x. In your lower grades, you were taught that whenever you're solving an exponential equation, what are you supposed to do? Make sure that there's one term on the left-hand side and one term on the right-hand side. Make the bases the same, then equate the exponent. So in this case, I'll make my bases the same. I'm sure almost all of us, we are already on the answer. Make the bases the same. It means I should write 8 as a number with a base of 2, which is 2 to the power of what? 3. Okay, now after the bases are the same, you then equate the exponent. Then you say, therefore, your x is equal to 3. That was purely grade 10. Okay, now the challenge in grade 10 was now when you are given something like this, it's 2 to the power of x equal to 9. Then they say solve for x. Goodness God. If you remember in grade 10, you started by saying, okay, fine. Still, I have to make the bases the same. Yes, make the bases the same. But now, what exponent should I put in that bracket to make sure that the right-hand side is also equal to 9? Then your teacher was now saying, let's investigate which number should we put there, and that number was coming out as a decimal. Until you locate the decimal that will give you an answer which is as close as possible to what? To 9. And it was quite taxing, it was quite involving. Hence, the logarithmic form was now developed to come and address and simplify that which the exponential equation had problems with. So let's appreciate the logarithmic function as a function which was developed to aid or to help the exponential function. So there's a very strong relationship between a logarithmic form and an exponential form, because the logarithmic form was just coming to address the problems that the exponential form had. Okay, fine. Now, let me look at the logarithmic form. I'm talking about the logarithmic form. You guys, you don't know what it is. So let me take you through so that we can appreciate it together. Okay, logarithmic the logarithmic form. Okay, logarithmic form. Log x base a, log x base a. We read this as, which is read as the logarithm of x base a. The logarithm of x base a, or in short, we can just say log x base a. That's how you read that that mathematical expression. The logarithm of x base a, or just the log of x base a. Right. Now, once you see that expression, please train yourself to read it properly so that when you interpret questions, you'll be able to reason with the expression. It's a complete mathematical expression, which means log x base a, right? This means log x base a. Very, very important. Okay, right. Now, just a quick note there. A quick note there. Right. The logarithmic form, or the log form, if I'll write it in short, is the inverse. It is the inverse of the exponential form. Okay, now there's a word inverse, and someone is already saying, now what is that inverse that you are talking about? Say, right, the inverse. We spoke about inverse processes in grade 10. We said the inverse process is also called the reverse process. Like the inverse of addition is subtraction. If I give you 10 rand, it means I've added 10 rand to your pocket. If I take it away, it means it is now the reverse of giving is taking away. The reverse of addition is subtraction. The reverse of addition is subtraction. The reverse of subtraction is addition. That's the other way around. Okay, right. The reverse of multiplication is division, and that of division is multiplication. The inverse of a square root, it is the square. And the inverse of a square is the square root. That was grade 10. The inverse of a cube root is the cube. And the inverse of a cube is the cube root. We did this. So the inverse of a logarithmic form is the exponential form. And that of the exponential form is the logarithmic form. So I can say, and vice versa. Let me just say, and vice versa. Okay, right. And vice versa. Okay, right. Now, if you look at this, this is very, very important. That relationship between these two functions is what we're going to be cherishing, and it's what we are going to be using in different applications. Okay, right. So let me just take you through the presentation on the logarithmic form and how it became the inverse process. Okay, right. So I'll start with what we call the exponential. You did this in grade 8, the exponential form. Okay, right. Let's look at the exponential form. In the exponential form, say if I'm given a number like 32, in exponential form, I can write it as 2 to the power of 5, where 32, this 32, we call it the number, right? And 2, we call it the base. This is the base, okay? And 5, we call it what? The exponent. Okay, if I raise the base to the power of 5, then I'll get my number as 32. That is basic. This is what we did in the lower grades. Okay, right. Then I'm now coming to the logarithmic form. Right, the logarithmic form. Okay, now let's look at this. Right, the logarithmic, if you've got something like this, log 32 base 2. Now, the first thing that I have to probably emphasize is log is a function which can be called from your calculator. If you go now to your calculator and check, you'll see there is a function or a key which is written log. In fact, there are two of them. There is another one which is log of a number like this with a box like that, and there is another one which is log and it's written number, then also in the base there is a space. If you go to your calculator, this is there. Okay, right. Now there you go. Look at this. The logarithm of a number 32 base of 2 is equal to what? That's what it means. So the logarithm of 32 base 2 is equal to, it means that which you are saying equal to becomes the logarithm, because you are saying the logarithm of 32 base 2 is. So that answer is the logarithm. Now, how do I get that answer? Mathematically, what are we saying? What are we trying to come up with? Look at this. It is as good as saying, what exponent should I give the base? What is your base there? Is 2. What exponent should I give to the base so that the answer is, or the number is 32? And that exponent is 5. Now, if you look at your exponential form and what I'm now calling the logarithmic form says logarithm of 32 base 2 is 5. And if you compare it with the exponential form, 32, it is still the number, but look at where the number of a logarithm is stationed. And 2 is still the base. This is the base. And 5, which was the exponent or the index on the other part, is now what we are calling what? The logarithm. So that which was the exponent is now what we are calling the logarithm. If you go to your calculator right now and you use the second key, which is log box, base box, and you press 32 in the first box and 2, you will see the answer is going to come out as what? As 5. Okay, so this is how the same facts that are in the exponential form are now going to be presented in the what? In the logarithmic form. So let me just give us a summary of what we'll be saying in the logarithmic form. In other words, let me just say NB this side. In other words, we are saying what exponent should be given to the base to get, in order for us to get the number 32. Right? What exponent to get our number is 32. And our answer is, let me hide that. Our answer is 5. So that 5 is what we are calling now the logarithm. Okay, right. So this is very, very important. This is very, very important reasoning. This is very, very important. This is summarizing the logarithmic form. So if I just quickly give you an illustration, just as examples, so that you can quickly process this. Look at this illustration. If I'm going to be given an incomplete statement like the first one, log, what is log 8 base 2? What is log 8 base 2? I said, think of the exponent that you should give the base. And my base in this case is 2. What exponent should I give to the base in order for me to get my number as 8? And that exponent is what? 3. So 3 is the logarithm. Right? Look at the next one. Just a quick one. Log 9 base of 3. What exponent should I give to 3 in order for me to get my number as 9? And that answer is what? 2. And that 2 is what we are now calling what? The logarithm. Something like that. That's very, very basic. Hope you now appreciate what a logarithmic form looks like. Okay, let's proceed. Let's proceed. Okay, right. So let me start by giving you an important note there. An important note, and this note says, the objective of this lesson is what? One should be able to convert from exponential. So if you are given something in exponential form, you should be able to convert it to log or logarithmic form. Okay, or the other way around, or the other way round, meaning to say you should also be able to convert from logarithmic to exponential. Okay, right. Now, how do I do that? I'll now state the classical definition of a logarithmic function. Right. The classical definition says if these are restrictions, if a is greater than what? 0, and a is not equal to 1. Remember, a is the base. So the base should never be less than 0, meaning to say the base of a logarithmic function is not supposed to be a negative, and the base should never be equal to 1, as well as x, the number, should always be greater than what? 0. Okay, right. Then what? Y equal to log x base a implies, I'm using a symbol there. This symbol means implies. Okay, right? Implies log x base a is the same as what? X equal to a to the power of what? Y. Okay, right. Very, very important. Very, very important. And this definition is going to help us convert from logarithmic form to logarithmic form. And from logarithmic form to exponential form, and from exponential form to logarithmic form. Okay, right. Now, the most important thing is when you are converting, you should be able to tell that x from one side, it is the number. And look at where the number is on your logarithmic form. And look at where the number is on exponential form. Right. So in a sense, we are saying what? The log y, in this case, y represents what? The log. So I can say log, which can also be exponent on the other end, is equal to log of a number. So this is where the number is stationed, and this is the base. This implies that the number is equal to, sorry about my space there, the base, just put capital letter B there, to the power exponent, which is now what? Which is now your logarithm. Okay, all right. Let me try to put it clearly there. That which you are calling the exponent or log is equal to the logarithm of the number. So that part on a logarithmic form represents the number, and this part represents the base, right? This implies that if you go to the exponential, this is now the number, and the number is equal to what? The base to the power what? The exponent, which is on the other end, the logarithm. Okay, this is very, 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 very important. It's going to help us. It's going to help us convert. Okay, right. Anyway, let's look at There are important facts that you should consider. There are some important facts, right, about this important facts. Right, basic facts that you need to consider there. The first one just says log of x. Right, log x. If once you are given something like log x and the base is not mentioned, then it means this is the same as log x base 10. Once the log is silent, like just log x, if you go to your calculator, you see there is just the one which is just saying log x. Right. Once they say log x, it means all those numbers are actually in base 10. So no base means base 10. No base means base 10. Okay, right. Now, the second one says what? Log x base x is equal to. Log x base x is equal to what? 1. In other words, I'm saying, what exponent should I give x so that my number is x? It's 1. Okay, right. Let's look at the third one. Let's look at the third one. We are looking at what? Log 1 base x. What exponent should I give to x in order for my number to be 1? 0. Okay, right. The fourth one there says log a base a to the power of x base a. The answer is going to be what? What exponent should I give to x so that my number is a to the power of x? So it means it's also x. Okay, that's very, very, very important. So those are important facts that you should consider before we go to the laws of logarithms. That will be in the next class. But these facts are discovered, or these facts are considered now that we know the definition of a what? Of a logarithm. Okay, fine. Now let's look at examples. Then we are done with this lesson. Okay, example number 1. Let's look at example number 1. Right, a very simple example says convert the following convert the following to logarithmic form. Convert it to logarithmic form. Right, how do I convert the first one? A, which is, say, 15 equal to what? 3 to the power of x. Right, I want to convert it to log form. Look at this. Right, in log form, this is going to be what? 15 is your number. 3 is the base. Remember, the base in exponential form is the base in logarithmic form. So I'm going to say log of the number. What is the number? It is 15. What is your base? Base 3. That should be equal to what? X. That which was the number, it is the number. 15 is the number in logarithmic form. But look at where the number is positioned. Right, that which is the base remains the base in logarithmic form. That which was the exponent is now the logarithm in the logarithmic form. Then you are done. I've converted. Very, very important. Now look at this. I'm given the next one, basic illustration. I'm given 4 to the power of x being equal to 17, and I'm just converting in this case to logarithmic form. This is exponential form because x is an exponent. So I can just simply come and say log that. This is going to be log of the number. What is your number? 17 is the number. So even if they twist and turn it, it's still fine. And what is your base? Your base is 4. The base in the exponential is the base in the logarithmic form. And this is going to be what? Equal to x. The exponent this side is the logarithmic that side. I've converted. Okay, let's go to the next example. Let's look at the next example there. Let's look at the next example. Simple example number 2. Example 2, it says what? Convert the following. Convert the following to what? To exponential form. So I'm now given something in log form, which is log 32 base 2 equal to what? 5. And I'm supposed to convert it to exponential form. Simple. In exponential form, remember, we start with the number. What is your number? Your number in this case is 32. Equal to the base. What is your base? It is what? 2. So this is going to be equal to what? What is your exponent? That which is the logarithm becomes the exponent. Okay, so in short, we are just saying log of a number base b is equal to what? The exponent. Say it e. This implies in logarithmic, in exponential form, the number is equal to the base to the power exponent, something like that. So this is the routine that you'll be using, and vice versa. Okay, given something in logarithmic form, you should be able to convert it. Let's look at the next one. It says a is equal to log x base b. Okay, right. I'm converting it to exponential. Look at that. Look at that. What is the number? In this case, our number is what? X. So it means x is equal to the base to the power a. I've converted. Okay, let's look at the next example there. Right. Example 3. Look at this. I'm now solving. Solve for x given that 2 to the power of x is equal to 21. Right. I'm now solving this. Simple, simple. If I'm to solve for x, this is 2 to the power of x equal to 21. The first thing is I'm going to say this is in exponential form. So I have to convert from exponential form to logarithmic form, right? In logarithmic form, I can say, therefore, this is the same as what? Log of the number, in this case, 21 is the number. So it's 21. The base is 2, which is equal to what? X. Okay, therefore, x is equal to log what? 21 base 2. Right. If you go to your calculator quickly and press in log 21 base 2, you go and pick the key which says log, then it puts a space and a space for the base. You press in 21 there, and you also press in 2 there. Okay. Then from there, I can now say this is going to be equal to, if your calculations are correct, that should be 1.89. I've solved for x to 2 decimal places. My last example there, our last example there is going to be what? Solve for m. Solve for m given that log 32 base m is equal to 5. Okay, right. There you go. I'm trying to solve this, so I'll come and say log of 32 base m is equal to 5. I'm solving for m. This is logarithmic form. For me to solve this, I have to convert it to exponential form. Convert this from logarithmic form to exponential form. Right, how do I do that? In exponential form, this is going to be 32, which is the number. Remember, in exponential form, it is the number equal to what? The base to the power exponent. Okay, so if I'm coming from logarithmic form, this is the number, which is 32, and m is the base. 5 is going to be now the exponent. So I'm going to say 32 is equal to the base. In this case, the base is 5. And the base is m. And the exponent is going to be 5. Now, solve for m, right? The inverse of the fifth power is the fifth root. So I'm going to say fifth root, both sides. This is going to be the fifth root of m, right? This is going to be what? Fifth root of this is 2 equal to m. So in this case, your m is equal to what? 2. There you go. This is how you would solve such a problem. Now, we are done with this section. The only thing left for you is to apply to as many problems as possible. But what was the main aim of this lesson? The main objective of this lesson was for learners to appreciate the logarithmic function. The second thing was to be able to convert from logarithmic form to exponential form to logarithmic form. Hope you guys managed to pick those two objectives, and going forward, you should be able to convert from logarithmic form to exponential form or vice versa. Okay, and another keynote which is very important, and I'm going to carry forward in other lessons, is that the logarithmic form is the inverse of the exponential form and vice versa. Thank you for your time, grade 12. Let's meet in the upcoming lesson. Thank you.